I don't teach you a lot about polymers, but there's a lot you can figure out just from what you know about functional groups and chemical reactions. So polymers are going to have repeating units, and the goal of a problem like this is to figure out what those repeating units are. So you can see we've got two carbonyls, so that's repeating. We've got NH, 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 and H, that's repeating. And you can see that there's a kind of back and forth repeat, carbonyl, carbonyl, NH, NH, carbonyl, carbonyl, NH, NH. Now you may recognize these as amide groups. So we've got this repeating unit, but to tell what pieces a polymer might come from, you've got to be able to break up the repeating unit. So you need a reaction that can split, in this case, amide groups. And we know that reaction is going to split in these locations and give us a carboxylic acid and an amine. So our object is to draw the carboxylic acid and the amine that will split in these ways. So I'm going to start here because I can see this entire unit. And I know this NH, when it becomes an amine, is going to have an H2. And then I have 1, 2, 3, 4 carbon. And then it connects to another NH, part of this amide. So I'm going to turn that NH into an amine. And I have my diamine drawn. Now I'm going to go to this where I can see the whole unit with the carbonyls. This double bond O is going to become a carboxylic acid. So I add the OH that's missing. I've got 2 more carbon and then another carbonyl. So I add the OH that's missing there. And now I have my diamine and my dicarboxylic acid. This is the kind of reaction that makes nylon. Nylon is a polymer made from a diamine, and sometimes, often instead of using a carboxylic acid, they're going to use a group that has a chlorine in the place of the OH. But if you have the right enzymes, you can do it with a carboxylic acid. You can do this reaction.